Oh, well, hello there. Today, we're going to look at a random discrete variable problem, and we're going to combine these random discrete variables. The story of today's problem is two people shooting free throws. Now, unlike most normal people who shoot free throws, there is no free throw shooting percentage overall. What they have is they have a probability associated with making a number of free throws. And so the story goes a little something like this. Each day after practice, Sam and Chris shoot free throws. Maybe they shoot 5 every day. And the little manager records how many they make each day. Here are their probabilities for each player. Sam, as you can see, has a 5% probability of making 0, 15% probability of making 1, all the way up to a 10% probability of making 5. S is the number of made free throws by Sam. Chris shoots free throws as well. Probabilities associated with Chris making 0 to 5 free throws. Set up like this is what we call a discrete random variable. Right? The random variable is the free throws. We want to know what's the probability that each player will make 0 to 5. And so as you know, we calculate the mean and the standard deviation for each shooter. I'm not going to go through those calculations here. I think you know how to do that. But I'm going to give you the values. So here's what we know. We know that the mean for Sam is 2.6. with a standard deviation of 1.281. Now, what does that mean? That means that Sam can expect to make 2.6 free throws each day after practice. When Sam doesn't make 2.6 free throws, the number that Sam makes will vary by 1.281. Do you remember those standard deviation meanings? I think you do. Okay? So in other words, S will vary from 2.6 on average by 1.281. That's what standard deviation and mean mean. Mu sub C. This is what Chris can expect to make. Chris can expect to make 3.15 free throws with a standard deviation of 1.236. Again, what will happen? C will vary from 3.15 by 1.236 on average. Okay. So some days Chris will make 0, some days Chris will make 5, but they will vary from 3.15. Okay. So it looks like after this data has been collected, the expected value for Chris is more than the expected value for Sam. Okay? So here's what I want to find out. Find the probability that Sam makes more than Chris. Now, you can look at this and you can say, well, Sam should average 2.6 and Chris should average 3.15. Does that mean that every day Chris wins? No. I mean, clearly some days Sam makes 5 and some days Chris makes 0, right? So we need to figure that out. And the way we're going to do this is we're actually going to find the sample space for all of this and compute all of the probabilities. Now, it's going to seem a little tedious, but it's going to show us how we can combine these two means and standard deviations. Let's take a look. So we want Sam to make more than Chris. In other words, we're going to let D, the difference, be S minus C. Okay? So, here we go. Let's first set up the average difference. So the average difference is going to be 2.6 minus 3.15. Okay? And this comes up to be negative 0.55. So what does that mean? All right, let's just think about that for a minute. This means that on average, right, Sam makes negative 0.55 free throws, or 0.55 free throws less than Chris, right? S minus C is negative 0.55. So on average, Sam makes 0.55 free throws less than Chris, fewer than Chris. We know how to calculate that combined standard deviation as well. You should remember this from your formulas in the book. Square root of the sum. Now, even though this is a difference, we still add, and this is where statistics students sometimes get in trouble. We subtract or add the means depending on what we're told to do, but for the standard deviations, we always add. Now, why is that? Because the standard deviation doesn't care whether you're adding or subtracting. As long as you're combining the variables, we still add. Okay, so what does that 1.78 mean? That means on average. Right? The difference, Sam and Chris's difference, will vary. Now fill in your sentence over there. Will vary from negative 0.55 by 1.78. And sure enough, if you think just a little bit, you can realize, hey, negative 0.55 plus 1.78, that's a positive number. So sometimes Sam minus Chris will be positive. And that's what we're looking for here. So we're going to investigate this question now. Let's take a look at what we've done, because these are applying the formulas here for discrete random variables. We know how to find the mean of a single random variable, right? Probability times outcome plus probability times outcome plus probability times outcome. We know how to find the standard deviation, right? The difference between the outcome and the mean squared times the probability, add them all. For the combined mean, you either add or subtract. And for the combined standard deviation, we take the square root of the sum of the squares. Yes, if you're thinking Pythagorean theorem, you are right on track. Okay, but now I'm interested in this question. So if you need to write this down, you can pause the video. But otherwise, we're going to now visit the question. So I'm going to pull a fresh screen over, but I'm going to leave those probabilities up because we're going to need them. So we want to find the probability that Sam makes more than Chris. So in other words, we want this difference to be positive, right? We want this difference to be positive. We want Sam to be greater than Chris. Now, in order to answer this, we're going to have to list some outcomes. This is the only way we can do this. So let's list Sam, Chris, and the probability. What are all the different ways Sam can win? Think about that. Can Sam win if Sam makes 0 free throws? If you said no, you'd be correct. Could Sam win if Sam makes 1 free throw? Well, yeah. What's the only way Sam wins? Chris has to make 0. And what's the probability of having that specific outcome? Well, it's going to be 0.15 for Sam times 0.05 for Chris. Let's see what else we can do. How else could Sam win? That's the only way Sam can win, by scoring one free throw. How about if Sam scores 2 free throws? When does Sam win? Sam wins if Chris gets 0 or if Chris gets 1. Let's do those probabilities. So Sam making 2 is 0.25. Chris making 0 is 0.05. And Chris making 1 is 0.05. All right, because 0 and 1 are the same probability there. Can Sam win any other way by making 2? If you said no, you would be correct. All right, let's have Sam make 3. What are the ways Sam can win if Sam makes 3? Chris could make 0, Chris could make 1, or Chris could make 2. And so you see what we're doing here? We're listing all of the ways. So this is actually counting up all of the outcomes. We're doing the entire sample space here. All right? Again, if this were a continuous random variable, we would just be using the normal curve. But it's a discrete random variable with specific probabilities. Okay, for 3 free throws, Sam makes these 35% of the time. Now we have to go through Chris, 0.05, 0.05, 0.1. And then how about if Sam makes 4? Again, I'm not saying these are likely outcomes, right? In fact, they're pretty unlikely, as these probabilities will show us. But these are all the different ways Sam can win. Because remember, we're looking for the probability that Sam makes more than Chris. Okay, 10% times 5%. That's a highly unlikely outcome, isn't it? 10% to 5%. Okay, again, 10% here at 4 for each of these outcomes. 1% for Chris. At 2, we're at 10%, and 3, we're at 45%. Okay, and then finally, in the highly unlikely outcome, that Sam makes all 5. 5 to 4, 5 to 3, 5 to 2, 5 to 1, and then squeeze it down here at the bottom, 5 to 0. And again, I encourage you, when I'm done with this, to pause it, multiply all of these out, and add them up with your calculator. And you'll get the total probability, and that's going to be the answer to the question. But let's see what we got here. So 5 to 4 would be, again, 10% each time. Now, how about Chris? 4. That's 2%. Or 20%, sorry. 20%, and then for 3, we're at 45%. At 2, we're at 10%. And then for 1 and 0, we're both at 5%. So that's the list of the outcomes where Sam makes more than Chris. And so if the question is, find the probability that Sam makes more than Chris, these are those outcomes. Now, there's a lot of other outcomes where Chris makes more than Sam, right? Then there's even a few outcomes where they make the same, right? There's actually 6 outcomes where they make the same. And so this is what we do. Now, I'll let you add this up and calculate it out, but basically you do 0.15 times 0.05, right? And then you do plus 0.25 times 0.05. You're adding up all of these probabilities. And that answer will be the probability that Sam makes more than Chris. But this is how we combine discrete random variables. Remember, the idea with the discrete random variable is that the probabilities are given in a table, right? And that's why these get a little bit more tricky. In our next video, we're going to do a continuous random variable where we basically use the normal curve from earlier in the course. So whenever I ask you these discrete probability problems, or you come across these, use the table, take a deep breath, and understand how we're calculating these, right? With the difference, we're going to combine the discrete random variables here and with the standard deviation here. And then if you're asked a specific question about the probabilities, you can make these kinds of tables. All right? So add those up, see what you get, and we'll talk about it in class. Okay? Have a great day, and we'll see you with some continuous random variables next.